Objective 4, quadratic functions. The last video said objective 2, should have said objective 4. Sorry about that. My mistake. We're going to back up a bit. We graphed parabolas or quadratic functions of this form by finding the vertex. Now we're going to back up a bit and say, suppose we have a function f of x equals x squared plus 4x plus 3, and we want to put that in this form and graph it. It's good algebra. Good algebra practice for calculus. This sort of algebra, rewriting expressions, permeates all of calculus, calculus 1 and especially calculus 2. So we're going to consider these two examples. The first example, x squared plus 4x plus 3 is equal to x squared plus 4x. We need to complete the square so we can factor. So we're going to add 4 over 2 squared. And then we bring down the plus 3. And then since we added that, we're going to subtract it here on the end. And that gives us x squared plus 4x plus 4 plus 3 minus 4. And if you look at the totality of this function, 4 minus 4 cancels, and that could take us back to the original function. But the important thing is we want this group together, and this factors as x plus 2 squared, and then 3 minus 4 is negative 1. And so, if necessary, the vertex is negative 2, negative 1. Okay, it was x minus h, so this is really x minus a negative 2, which is negative 2. And then that is the vertex. Now, the second problem is a little more difficult. We need to factor the 2 out. Of these two terms. Don't worry about this for the time being. And that way we can put it in this form. The perfect square formula counts on it being 1x squared, not 2x squared. Now what are we going to add? Well, we're going to add 4 over 2 squared end parentheses. Bring down the minus 5. And now we need to subtract out what we added in, but you have to be careful. We added in this product. So we're going to subtract out 2 times 4 over 2 squared. This is equal to 2 times x plus 2 squared minus 5 minus 2 times 4. 2 over 2 squared is 4. And that's equal to 2 times x plus 2 squared. That's minus 8 minus 5 minus 13. Okay, and you can add, subtract however many steps you want. The vertex is negative 2, negative 13 in that case. Okay. Second type of problem we consider. Suppose we have a couple points. Suppose we have a vertex 2, 3 and a point 3, 8. And we know this is a vertex, this is a turning point, so we have something like this going on. We have half the parabola. Let's see if we can figure out what the function is given this. We're really looking at all sides of this parabola question. Well, first of all, we know that hk is 2, 3. V of 2, 3 is just a fancy way of saying hk is 2, 3. And then we can substitute f of x equals a times x minus 2 squared plus 3. Just put h here and k here. The only question remains is what is a? Well, when we say the point is 3, 8, we are really saying that xy is 3, 8. And so we can put 8 in for f. Put 3 in for x. Okay, a stays a variable. Plus 3. And now we can solve for the parameter a. So 8, that's just 1 squared is a plus 3. So a is equal to 5. And so the function, the quadratic function of the form ax minus a squared plus k is f of x is 5, x minus 2 squared plus 3. And of course you can graph it. Another way to go about this, by the way, is there's other ways to solve this problem. Is if we have the vertexes here, 2, 3, and this point is 3, 8. Okay, by symmetry, there's another point over here. See, if you go to the right one, we go up to 8. If you go left 1 to 1, we also go up to 8. So you can plug these 3 points in, solve for a, b, and c. A little more work. 3 equations, 3 unknowns. You could end up with a, b, and c. Of course, you wouldn't have it in this form. You'd have to apply the previous method to complete the square, et cetera, et cetera. A good exercise. You could work your way all the way around these parabolas. So that's it for this video.